All right, welcome everyone to the webinar. I'm going to wait for some more people to sign in. I know we might have some more libraries that are coming on in, but my name is Lily and I'm at Calaveras Big Tree State Park. And we're going to take a little walk through the woods we have here, right? This is about wandering through the woods. So we're going to take a little walk through the woods we have here, talk about giant sequoia trees like this one behind me, as well as some of the other trees that call this forest home. We're going to talk a little bit about how these trees are similar, how they're different, and we're going to cover a little bit of the history of this park because it's pretty interesting. It's really important for understanding our relationship with this really majestic tree, the giant sequoia. So I see some more participants coming on. Welcome, welcome. I do want to say, because this is a library event, that there is this really cool library state park association that has started semi-recently, where libraries can give you a state park pass as long as you are a library member. And we have this lovely graphic for you to look at. So you can come visit state parks like Calaveras Big Tree State Park for free. If you just go to your local library, you have a library account with them, and you get a state parks pass, come in here, spend the day here, enjoy these giant sequoias. So it's a really cool system, and I'll be talking about it a little bit again at the end. And I do want to say this is one of a couple programs we've done with libraries over this month. We'll have another one later on. We'll plug that at the end too. All right. So if you missed it, my name's Lily. We're at Calaveras Big Tree State Parks, but that's not super clear. I told you I'm at Calaveras Big Tree State Park. Where is that exactly? Well, I went to Google and I just said, okay, I'm right here. You can see it says work. I'm at work. But let's zoom this out a whole lot so you can get kind of more context to where is Calaveras Big Trees. Maybe see some names you recognize as I zoom out here. There is Sacramento, right? Our capital. Zooming out some more, you can see that not terribly far away from like San Francisco and all that. Zoom it out even more. That's kind of centered a little bit. You can tell I'm kind of in like the northern middle part of California. But what's really most significant, at least for this park, is how close I am to the border of Nevada. It's right there. Now, I'm not directly at the border, but because I'm kind of nearby, that means I'm in the Sierra Nevada mountains, that mountain range that pretty much divides our two states. Now, since I'm not like closer to the border, I'm not at the top of the mountains. I'm not way high up there, but I'm at what's called the foothills of the Sierra Nevadas. So just like how the feet are at the bottom of your body, I'm at the bottom of the mountains. And I mention that because the foothills of Sierra Nevada on this side of the state is the only place the giant sequoia like to live. They only live like right around there. That's it. They're not found anywhere else in the whole wide world, at least not naturally, right? You are welcome to plant giant sequoias and all that. That's just not where they naturally live, except for here. But why am I even talking about giant sequoias? Well, these are amazing trees. The giant sequoia is the biggest individual tree to have ever lived. And trees can get quite big. So that means it's bigger than any dinosaurs to have ever lived. It's bigger than the currently living blue whale, which is the biggest animal. It takes 3 blue whales, stacked nose to tail, to get as big as the biggest giant sequoia. These are massive trees. Now, this tree behind me is not the biggest one ever. We don't have that one here in this park. That's in a park called Sequoia Kings Canyon National Park. But this is the biggest living one that I also have internet connection to. So it's a great one for these programs. So I'm gonna give you kind of a sense for how big this tree is. This one's right along the trail, so it's okay to walk right up to it. And I'm stretching my arms out. And you can see, like, I'm trying to reach all the way across, and I'm not even getting close. To be fair, I'm not a very big person, but my wingspan is about 5 feet. So from fingertip to fingertips, about 5 feet. So this tree is maybe like 10 feet across or so. But this bigness I'm talking about for giant sequoias is not just their width across, it's also how tall they are going up. So let's take a look at how tall this tree is here. Start off at the bottom. You can see a couple of roots poking up out of the ground. Now let's go all the way up. All right, there it is. There's the top of the tree. These trees are huge. So I told you this one, using like roughly my hands, is about 10 feet across, right? Well, the very biggest one across, biggest one overall too, if you count up its total volume, is the General Sherman tree. Again, not found here, found in Sequoia Kings Canyon National Park. But since my wingspan's about 5 feet, it would take 7 of me to stretch across the General Sherman tree. Now, if you want to do some kind of quick math in your head there, that means that it would be 35, technically it's 36, but about 35 feet across. Now, the very tallest giant sequoias can be up to 300 feet up. Again, add it all up, you get the biggest individual tree ever. Bigger than any animals we have for sure. But for me, if I say, okay, we have this really cool tree, it's really huge, I just wonder how? How can something get to be so big? Well, like any plant, the giant sequoia does need things to grow, just like how we need things to grow. It needs to be able to take care of itself. So it needs water, carbon dioxide in the air, and it needs sun. They use all those, mix it all up to make their own food. They need those things to grow. Giant sequoia likes to have a lot of space. Being a really big tree, they like as much space as possible. But they also need one other thing, and something we need too, and that's time. They need time to grow and get super huge. But while we stop growing, they don't stop during the entire time they're alive, as long as they have everything they need. And the oldest giant sequoia found so far is 3,200 years old, which means that its seed, these trees start out as seeds, they land to the ground and started growing, the oldest one, during the Egyptian Empire. All right. And it was still growing during the Romans and the Vikings and the Renaissance era when the Mona Lisa was painted and all those other famous paintings were painted. And it's still living and growing today. So that's how they can get to be so huge. They're really old. And if you think about it, if we could live for 3,200 years and we didn't stop growing, we'd be pretty big too. So it kind of makes sense. But we don't live for 3,200 years. We can't do that. And it'd be hard for any living thing to live for that long. They need a lot of adaptations in order to live for that long. And adaptation is any sort of characteristic or trait a living thing has to help it survive and thrive in its environment and how it wants to live. By thrive, I mean maybe this living thing wants to have lots of kids. Maybe this living thing wants to live a very long time. And that's what the giant sequoia is striving for. Now, its main adaptation to handle all these things is its bark. Now, it's the real giant sequoia behind me, but I want to give you all a nice up-close look at the bark. All right. This is just a very slim section of the bark, because the bark of a giant sequoia can be 2 feet thick. 2 feet right here. That's the length of my arm. That's how thick the bark is. And the bark of a tree is basically like the skin in our body. It helps protect the tree from anything outside trying to kind of attack it and get in. So imagine if your skin was 2 feet thick. I mean, that'd be disgusting, but you also probably would never get a cut again. That's sort of the same concept for this tree. With bark really thick, it can defend itself from all sorts of things. It's harder for animals if they're like scratching at the bark. We do have bears here. It'd be hard for bears maybe scratching at the bark to actually hurt the tree because there's so much of a protective layer. It's hard for fungi to get at the tree as well. So mushrooms and things that might kind of hurt the tree a bit. But most importantly, it also helps the tree survive fire. Now, fire is a natural part of this forest. Not nowadays, but way back when, it would burn every about 7 to 12 years. But if your bark is 2 feet thick and it's protecting the rest of the tree, it's hard for a fire to burn all 2 feet and then get to that part of the tree and impact the trees underneath the bark. If you've ever thrown a log on a fire, you'll know that 2 feet, that's a lot of wood to burn. So it really protects the tree and keeps it surviving from various fires. Now, not all fires, some fires are too intense and the trees can't handle it, but a nice kind of low burning fire having bark this thick really helps the tree survive. That's one part of the bark. There's actually another part that's, if not more important, at least equally as important. And that's the fact that it is this beautiful red color, all right? This red is not found in all trees. In fact, it's not found in probably most trees. And this red comes from a bunch of different chemicals. One in particular is this group called tannins. That's T-A-N-N-I-N-S, tannins. And tannins are incredibly bitter. They're actually found in small amounts in black coffee, black tea, adults also found in red wine. And those are all things that are pretty bitter, right? So imagine if you're an insect and you're chewing on a giant sequoia and you're tasting something so bitter, it's like way better than any black tea, black coffee, anything else you've ever had before. It tastes disgusting. So you're gonna go chew on another tree, like maybe this tree over here. This tree doesn't have those red bark. This tree doesn't have the tannins, so it tastes okay. So having this red color really helps make sure insects are less likely to chew away at this tree and potentially eat the tree and kill the tree. So these guys are they're not invincible, but they're pretty good at defending themselves from all the things that might 3,000 years it can be alive. I talked about before, like this tree, not all these trees have these tannins. The giant sequoia isn't the only tree found in this forest. So I'm going to now turn the camera around and go on a walk on the trail I mentioned we're right next to. And we're going to take a look at some of the other trees that live in this forest and do a little wandering in the woods. Now, not all these trees, but most of these really big trees we see here are trees that are called conifers. And conifers have needles. The needles are just different versions of the leaf. So let's get kind of up close to this conifer here. This is a white fir. You can see, looks maybe a little like a Christmas tree at home or something, right? The needles or leaves are very long, very slender, and they usually stay on the tree year round. So they're often called evergreen as well. Now you see some other trees around here that are not super big, but they have these nice big leaves here. These are broadleaf trees. And this particular one I'm showing you guys is a dogwood. We have lots of dogwoods. They're not very tall, so some people call them more like shrubs instead of trees. But we got pretty good diversity here. One other kind of tree / shrub I'm going to show you is this one here. You can see it's a little bit different from a dogwood. The leaves are maybe a little bit more serrated, we call it. So that means there's lots of pokey parts on it. This is a hazelnut. So we got the hazelnut, we got the dogwood, but we have a bunch of those conifers with their needles. Now I'm going to turn my camera back around here. And we're going to talk some more about conifers and give you some cones they have. So not only do conifers have the needles, but they have the cones. And cones are how they carry their seeds. So just like how a fruit tree carries its seeds inside of fruit, conifers carry their seeds inside of cones. That's a good way to remember the term conifer too. Conifers have cones. They also have needles. So I'm now going to show you 4 different kinds of cones from 4 different kinds of conifers. I'm going to show them to you, all of them. And then I want you in your little groups or in your big groups to kind of decide, you can do a little vote if you like, which one you think came from the giant sequoia. Because the giant sequoia is one of the conifer trees we have here. So I'm gonna get my cones all out and ready to show you. All right, so we have the very first cone. Just gonna call it cone number 1. We have this one. This came from one of our conifer trees. Maybe you've seen something similar before. It's very spiky, all right? It's a little bit difficult to hold this without poking yourself a little bit. But that's cone number 1. We have cone number 2. We have this cone. All right. It's pretty small compared to the first one. It's nice and smooth though, not pokey at all. It's cone number 2. We have cone number 3. We have this one, which looks nothing like the other ones, but it is a cone from a conifer, carries the seeds, just does it a little differently. And then we have cone number 4. We have this one. All right. These are all real cones, all found in this forest, but only one of them came from the giant sequoia. So now is when I want you to kind of discuss amongst yourselves, figure out which one you think might be the giant sequoia. I'll show them to you all again so you can remember. So we have the first one. We have cone number 1, right? Pokey. Maybe you kind of recognize it. We have cone number 2. We have this one, right? Small, smooth, kind of egg-shaped. We have cone number 3. Weird one. Looks like almost a flower, kind of. And then we have cone number 4. The very long one. All right, make your decisions. I'm going to do the grand reveal for which one's a giant sequoia cone. In 5, 4, 3, 2, 1. It's cone number 2. It's this one. It's not the littlest one, but definitely one of the smaller ones. This cone carries the seeds of the biggest individual tree in the whole wide world. Just wild, right? But that's the way it works sometimes in nature. It doesn't always line up perfectly with what you expect, but this is just whatever worked to help the giant sequoia last for a very long time and each individual tree live, hopefully for a really long time. So we'll show you the other ones. Cone number 1, which is this one. This came from Ponderosa pine tree. And as I walk down the trail a bit further, I'll be showing you which tree came with which cone. So I'll show you what they look like. But this is a Ponderosa pine cone. All right. And then we also have the really weird one. Actually, I'm going to show you a slightly different example of it. This one. This came from the incense cedar. And I don't even walk very far for that, because this right here is an incense cedar. You can see that bark is also kind of reddish. They have a little bit of those tannins I told you about before. And that's because they're actually a very distant relative of giant sequoia. Not like crazy distant, but think third cousin once removed. So if you were thinking this one came from the giant sequoia, you're not too wrong. At one point, these came from the same tree. And I usually have people wondering about this. I want to tell y'all, all these little holes here are from woodpeckers. I told you we have bears here. Maybe might scratch at a tree. We also have lots of woodpeckers that love to look for insects or maybe make the tree draw out sap by poking at these trees. That doesn't usually hurt the tree too much. If there's a ton of woodpeckers at one tree, that could cause problems. But they usually only do that to a tree that's already dead because there's lots of insects inside of a dead tree eating it up. But woodpeckers, and this is an incense cedar. And then finally, the last one, which I'm guessing a lot of you thought might be giant sequoia, the big one. This came from a sugar pine tree. And sugar pine trees are the biggest of the pine trees, but they're nowhere near as big as a giant sequoia. They just have ginormous cones, partially because they want to tempt animals to pick up these cones and eat away at the seeds that are tucked away in the middle. And once the animals start doing that, the cone tends to kind of get real skinny, and it looks a little bit like corn on the cob. This is after maybe a bird has been poking away at this cone looking for the seeds. So if you're in a park like this one, and you see a really cool cone like this, please don't take it home with you. I know it's tempting because it looks so cool. You can pick it up and take a picture of it, but leave it behind because it's actually a really important food source for our squirrels and our birds and other critters in here. And even if all the seeds are gone, it's not a food source for the animals anymore, it's also eventually going to be a food source for the other trees and plants here because they'll decompose and make some really good soil. So take a look, take a picture, but don't take it home with you. Now let's go back to that giant sequoia, its cone, and I want to show you its seeds. Little cone, itty bitty seeds. Each one of these is a giant sequoia seed. They're smaller than an oatmeal flake, but they look kind of like it. It's a little hard to tell with the sun right now, but each one of these seeds is a little dark stripe down the middle. That's a part that actually grows into a giant sequoia. The kind of tan parts on either side, those are the wings of the seed. Just like how dandelions have the fluff to help their seeds fly further away, the giant sequoia has these little tan parts on either side to help the seed flutter away from the mother tree. They want to make sure the seeds spread out as much as they can, so not fighting with each other for resources. And they're so little that they're really lightweight, and that works really well. But because they're so little, it's not very likely every single one of these is going to survive. So instead of just making a few seeds and being like, I'm putting all my energy and effort into you, you guys better do well and grow big, giant sequoia instead makes as many seeds as possible and kind of crosses the fingers that one of them will land in a really good area where it could grow to be a really big tree. Most of them aren't going to make it. So they can have up to 200 seeds in each cone, and they can have thousands of cones on each tree. So hopefully one of these little seeds will make it and survive. Now there is a way for the giant sequoia to release its seeds at a strategic time so they can grow pretty big, or it's more likely they'll grow into a pretty big tree. We're going to talk about that, but I want to show you as we walk to our last destination along this trail, more of the trail itself, and point out a couple of the trees like I said I would. All right. Now, I showed you the white fir earlier. I didn't show you its cone because its cone actually falls apart really quickly. So it's hard to find an example of it to use for programs. But right here, we have a ponderosa pine. It's got really pretty bark that looks a little bit like puzzle pieces. And it has needles that are really long and kind of in a bundle. Not even kind of, they are in a bundle. They look like this, all right? So that's a ponderosa pine. And then over here, so I'm walking towards a really big tree and ooh, a very big stump. This is a sugar pine tree. All right, you can tell it's pretty big, right? It's also pretty tall, just nowhere near as big as the giant sequoia. All right. And they also have needles, just like the ponderosa pine. Their needles are a little bit shorter, a little bit stubbier. I'm gonna pick some up off the ground here to show you. Their needles look a little something like this, kind of short and stubby. All right. But told you, okay, not all giant sequoias are going to grow huge because those seeds aren't all going to make it. But giant sequoia can kind of think and plan for when to release the seeds at the best times to make sure they get as big as maybe this stump was. Giant sequoias will actually release their seeds after a fire. They will open up their cones and release them after signs of smoke and heat. That's because their seeds really like lots of open space, so you don't have to compete with other living things. And they love a ton of sun. So again, open space, lots of sun. And they want to be able to easily access all the good soils underneath what we call the leaf litter. So that's needles, pieces of bark, things like that. They're on top of the forest floor. Now, as I mentioned, not all fires are equal. So a nice slow burn is usually what they're hoping for. And after that, we can get lots of big trees like this one. And we are doing some fire strategies right now to try to promote that sort of growth. We're starting our own fires very safely. They're called prescribed fires to promote the growth and to maybe prevent us from having even bigger fires that are a bit more dangerous. Because we want to have trees as big as what this one used to be. Now this tree, this stump, has its own story. It's called the Discovery Tree / Discovery Stump because it was the first giant sequoia seen by non-Native Americans, at least the first one to really spark international and national interest. The Native Americans here, the Miwok and the Washoe, they've known about these trees for a very, very long time. But when the gold miners came here looking for gold, they also saw these trees and were astounded by them. So much so that unfortunately, this one was cut down basically for tourism. They decided to cut it down, strip away the bark, so they could reassemble the bark and show it off in places like San Francisco and then New York and London for people who have never seen these trees before, and take chunks of the tree and showcase them also in those same locations. The idea was to make some money from those exhibits, but also to say, hey, people who are not right here, you should come here, maybe stay at one of our hotels and take a look at these giant sequoias yourself. So it's not great because this was killed for tourism, but it did draw people here. And a lot of people, even at the time, were mad this tree was cut down. So it did eventually spark the movement that led to us becoming a state park for you all to enjoy. So this tree was also the biggest one in our park. And I'm going to take you on one edge of the stump and walk to the other side so you can get a sense for how wide these trees can get. Again, General Sherman, still the biggest one. This tree, given the chance to grow, might have been even bigger than that. We'll never know for sure because this was cut down in the 1850s. But I am right now about 25 feet away from you. This didn't have any bark on it. Bark's 2 feet thick, so you can add another 4 feet or so. We have about 29 feet across when it was still alive. They grow pretty quickly. So this one might have been that 35, 36 feet the General Sherman is. Its height, we're not positive, but 280 to maybe 300 feet up. And this tree was 1,244 years old when it was cut down. So still had maybe another 2,000 years to live if it wasn't cut. But again, at least it resulted in this becoming a state park. So we do live and learn a little bit. And at least this is still here as a good opportunity for people to understand how huge these trees can get and to learn from our mistakes in the past, which is really what's key to kind of keep us going forward in the future. So if you all do end up coming up to visit and checking out this stump, since we're kind of nearing the end of the program, I want to do another plug that you can use your library, your local library, to get a state parks pass to come to this park or any other state park for free. So if you want to come by and you're like, well, I don't know if I want to, pay the day fee, you don't even have to. Just go to your library and get a state park pass and come up here, check out this huge stump, look at all these other awesome trees we have here, and you can do that. And we do have one more program coming up as a part of this library's presentations at Citrus State Historic Park. All right, 22nd July, 12 p.m. Definitely go by and check out that one. Different from this park. We have such a huge variety of parks in California. We're really, really lucky to have that. So now, oh yes, also another reminder, use the library pass. This is what it looks like. Please use that if you're going to come by and visit. And if you do happen to come by and visit Calaveras Big Trees, feel free to ask if my name is Lily, if I'm around, and I'd love to say hello. But I do want to ask our panelists if there's anyone who has questions in these last few minutes we have. And I don't have a hard deadline of ending at 11:30. So if we go a little over, that's okay. I want to hear from you if there's any questions about this park or about the giant sequoias.
Awesome. Thank you so much, Lily. That was so interesting. Let's see, we did have some that were sent in. If anybody has any while I'm asking these ones, go ahead and ask, and I'll ask her as well. So we had one question sent in. I'm sorry, I wrote them down as they were coming in and then I left the page. Okay. So you talked a little bit about the bugs that weren't eating the sequoia, but what animals live in the sequoia? Are there any animals that kind of depend on that tree?
Yeah, great question. So there are animals that depend on the tree. One in particular is a kind of squirrel that's called a chicory. It's also called a Douglas squirrel. They actually love to eat around the cone of the giant sequoia. They don't eat the seeds, but they do like to eat around the cone. That also actually helps release the seeds if they're not open from something else. Chicory would open them up. And the bark of a giant sequoia, because of those tannins, not only does it help it repel insects, but also tends to repel disease. So if there's a squirrel living inside the bark, it's unlikely to have things like ticks and all that. So they actually love to live inside the bark to help get rid of any sort of gross things that might be attached to their fur. So they really like to live in there. And that also means that other animals, like I mentioned, woodpeckers, lots of woodpeckers like to live in giant sequoias too.
Awesome, thank you. And then we had a, yes? Are you guys open all year round or are there only certain seasons?
Yeah, we are open year round. Not all of the park is open year round. I'm right now what's called the North Grove. I'm right by the visitor center. This is open year round, but we do have a long stretch of road that goes down to other parts in our park. That's closed in the wintertime because we just can't maintain it when we get snow and ice, which we do every winter. So if you do come in the winter, you're welcome to check out the bits that are open and just make sure you come prepared with your gear because we do get a fair amount of snow here often. So bring warm clothes, maybe snowshoes if you have them, chains for your tires, all that.
Awesome. Of course. Let's see. Another one we had was there are so many different kinds of pine cones. How do trees choose what their pine cones look like? And are all of the nuts in the pine cones edible?
Yeah. So I'll answer the nuts and the pine cones one first and kind of go back. So often trees decide the shape and the way their cones are based off of what works for them in terms of having successful seeds. So seeds we eat, like pine nuts, the sugar pine cone I showed you, I'll just go ahead and grab it again and show it to you again. Technically, you could eat these seeds just like the pine nuts you buy in the grocery store. The ones you buy in the grocery store just aren't from sugar pine, they're from similar trees, but you could. And their strategy is to have animals want to eat the seeds. So then they take the whole cone or take at least a part of the cone to their home and spread the seeds that way. So that's why this one is so big. They want bigger animals to disperse their seeds really well. So they're not all fighting each other for the same resources. Cones are really little. Shapes are kind of hard to determine, but the little ones have the little seeds that are lightweight. So then, like I mentioned, the wind can distribute them better. So in general, bigger is like, okay, animals, I want you to distribute me. I want you to want to eat my seeds. And the little ones are for, I don't want to be eaten. I'm going to rely on wind or something similar to help me disperse. Actual shape and size, it's just kind of whatever is worked out over however long these things have been species. But general bulk depends on how they want to disperse their seeds.
Awesome, thank you. Let's see. When did you guys become a state park?
Yeah, we became a state park in 1931. So remember, I mentioned this was cut down in the 1850s. So it did take quite a long time for us to become a state park. There was one other tree that was negatively impacted by tourism here. It's called the Mother of the Forest. They also stripped the bark from the tree. While they didn't cut it down, stripping the bark from the tree, we mentioned how important the bark is for the tree to survive things. It did eventually result in that tree dying. But luckily, those are only two trees that died for the sake of tourism here. And soon after those were killed, that sort of practice was put to an end because enough people were mad about it. And there are many attempts to make it a state park or even a national park, but it wasn't until 1931 that it happened. So it took a while, but people were still very good about protecting the park from this sort of thing after these happened in like the 1860s onward.
And then this one, how many trees come from Sequoia? If the Sequoia trees are alive, does that make them the biggest living thing in the world? Or are there other trees bigger than that?
Great question, because this is actually something I love to talk about. I have a whole other program about this. They are not the biggest individual thing that's alive. If we're talking about one single organism, there is a fungus that's actually called the humongous fungus. It's found in Oregon. Let's see, the number is a little bit off, but I think it's either 3.1 or 3.4 square miles, one individual thing. It's mostly underground, so it's hard to see it, but its fruiting bodies, which are the little traditional mushrooms with the stem and the cap, you know, they see poking out of the ground, those can be seen all over. And scientists have figured out that is one ginormous living thing. So that's the biggest individual thing. Other living things can clone themselves. So you can debate if they are the same thing or not. Like, are clones all one organism? I don't know. But tree-wise, quaking aspen, there's this really pretty tree. They're broadleaf, so they don't have needles. They can clone themselves. So they are the biggest tree because there is one that's 40,000 trees. That's one quaking aspen because it's a clone of 40,000 of them. That's found in Utah. It's called Pando. And then, yeah, that's pretty much it in terms of that for trees and individual. If we want to even further, there's another organism that's a seagrass that also can clone itself. Recently found in Australia, like 3 weeks ago. This is news. It's about 77 square miles. It's all one living thing that's cloned itself, and it's the seagrass. So that's why I say biggest individual tree. And that's not this, I should say, individual tree, giant sequoia.
Very nice. All right, and we have one last question that I see. It's about you. How did you become a park ranger, and why do you like doing it?
Yeah, so I've been doing this sort of job for about 5 years now, I guess. I used to work for national parks and the Forest Service before I got state park position, but I'm from California and I love giant sequoias, so I'm quite happy here. And I didn't always know I wanted to be a park ranger, and I do want to stress that. A lot of my coworkers, this isn't their first idea for what they want to do, but as long as you have experience in and this is a specific kind of park position. I'm technically what's called an interpreter, not technically a ranger. An interpreter is someone who gives programs. You can work for state parks and not be like me, public facing. You can work to help manage the forests, you can do law enforcement, you can build trails. There's all sorts of different things you can do within the park. But if you want to work like I am doing what's called interpretation, it's just good to have a background in the sort of thing your park's talking about, whether it's like history or nature, the sort of thing, and some sort of teaching experience. So for me, I do have a degree in ecology, which is the study of why things work basically in nature, but I also had background in teaching. I volunteered teaching and I did tutoring and all that. So that's how I got kind of my start, is I already had the background. I had also experience doing this sort of thing. And then once I got an internship with the Forest Service and I realized this is what I wanted to do, I stuck with it. But I know people with international business degrees who are a park ranger for the Forest Service. So you don't have to know ahead of time what you want to do if you want to do this. But it's good to get that sort of outdoorsy or history or teaching experience going in so you can kind of prove to the park, hey, I know at least a little bit of what I'm doing.
Awesome. Thank you so much. We don't
Yeah,
have any more questions. However,
perfect.
we do have though, for our summer reading program, if anybody is listening in, our secret code for the week is big trees. All trees is capitalized.
Good secret code. We do have big trees here.
Absolutely. Thank you so much, Lily.
You're very welcome. Goodbye, everybody.